So now we're going to compare these equations to the parent function without graphing them, which I know sounds like it might be a little challenging, but we take it one step at a time. So the first thing that we can do is we can determine if it has the same direction or a different direction from the parent graph. Remember that my parent function has a positive slope. So to change the direction, I would have to go from a positive slope to a negative slope. What about this first one? Is 2x, is that 2 a positive or negative? It's positive, so it would be the same direction as my parent function. However, negative 1/4, I've gone from a positive to a negative, so this would be a different direction. Then I have a negative 7/3, so this would be a different direction, and a positive 2/3, the same direction. Okay? Now that we've talked about the direction, so changing the sign of my slope changes the direction, let's talk about the steepness. The steepness of my slope is controlled by the slope itself, the value. So in my parent function, the slope is 1. If my slope of my new line is larger than 1, it's going to be steeper. If it's less than 1, it would be less steep. And if it was 1, it would be the same. So let's talk about 2. Is 2 steeper or less steep? 2 is steeper. And what about 1/4? Is 1/4 steeper or less steep? Well, is 1/4 less than or greater than 1? It's less than, so it would be less steep. 7/3? Oh, 7/3 is a tricky one because 7/3 is an improper fraction. 7/3, if I were to write that as a mixed number, would be 2 1/3. Is 2 1/3 larger or smaller than 1? It's larger, so this would be steeper. And then I have 2/3. Is 2/3 larger or smaller than 1? It's smaller, so this would be less steep. So I can control, or I can not control, I can predict what the direction of my line is going to look like by looking at the sign of the slope. And I can predict the steepness of the line by looking at the value of the slope itself.